Again, welcome to Mathematics 164 Pre-Calculus. Today our topic is solution of linear equations and also inequalities in one variable. But we're going to focus more on the linear equations today. So solution of linear equations. Here we're going to learn how to solve linear equations in one variable and also to solve a prior problem by using linear equations. Also to solve linear inequalities in one variable. So what is an equation? We saw a function or algebraic expression, but the difference between equation and an expression is the equal sign. So for example, here I have 3x minus 2 equal to 7. This is known as equation in one variable. Our variable is x. So here we can solve for so x will be a variable and it's the unknown value that we want to solve. So if I want to solve for 3x minus 2 equal to 7, the first thing we should know is that anytime a negative value cross an equal sign or a negative variable, it can be expression, cross an equal sign, the sign changes to positive. Also, if a positive cross an equal sign, the sign changes to negative. Now, if you have a multiplication like 3 times x, if I want to move 3 to the right side of the equal sign, is going to divide. So multiplication cross equal sign, divide. Addition, subtraction. Subtraction, multiplication. Subtraction is addition. Then division is multiplication. So I will say that positive is inverse of negative, or negative is inverse of positive. Then multiplication is division. Division is inverse of multiplication. So if I want to solve this problem, what I'll do first is that I'll take minus 2 to the right side. So minus 2 becomes positive 2. So 7 plus 2 is 9. So I'll get 3x equal to 9. Now, since 3 is multiplied by x, if you cross the equal sign, it's going to divide. So we get x equal to 9 divided by 3. And the solution will be 3. Now, if I put 3 in the variable here, the equation is supposed to balance. So 3 times 3 is 9. 9 minus 2 is 7. So 7 equal to 7, which means the solution is correct. Also, a value of the variable x always will determine whether the equation is true, as I did example here. A value of a variable that makes the equation true is called the solution of the equation. So here the solution of our equation is s equal to 3. And if I substitute s with 3, the equation will balance and it will be 7 equal to 7. So the variable is in an equation is sometimes called unknown. As I said earlier, x is unknown value. We calculated for it. Now, example, we have another equation here. 2 parenthesis s minus 1. So this is the same as saying 2 times x and then 2 times negative 1. So you get 2s minus 2. This is an example of an identity. So this is also the properties of equality, the equations. So for example, if I have 3s minus 3 minus half 4s minus 18 equal to 4, we say it's equivalent to 3s minus 9. Why? Because 3 is multiplied by the items in the parentheses. So it will be 3 times s is 3s, 3 times 3 is 9, negative 9. Now, half will multiply everything inside the parentheses. So half times 4s will be 2x. Then half times 18 will be 9. But negative times negative will give me positive. And negative times positive will give me negative. And here we can solve for the equation. So for example, here we say the solution x equal to 4. But we can check and see. I have 3x minus 2x. So 3x minus 2x will give me 1x. Now, negative 9 and positive 9 will do what? They will cancel. So the final solution will be s equal to 4. Because positive 9 minus 9 is 0. And 3s minus 2s is x. So s equal to 4. This is substitution property. Now, addition property means, for example, as I said earlier, if I have negative 4, when it crosses the equal sign, it's going to add. So you can see that s minus 4 equal to 6 is equivalent to s minus 4 plus 4. Since I had plus 4 to the left side, I'm going to have plus 4 to the right. But the goal again is to cancel minus 4, so I need plus 4. So you can see that we have plus 4 in the left, another plus 4 to the right. So this will give me s equal to 10. Because minus 4 and plus 4 will cancel. Then 6 plus 4 will give me 10. Here also we have s plus 5 equal to 12. So now it's positive. So we need negative 5 to cancel the positive 5. So we have negative 5. And since we have negative 5 to the left side of the equal sign, we need the same negative 5 to the right side of the equal sign. So we get 12 plus negative 5. And 12 minus 5 is 7. So the solution will be 7. So we can see multiplication is division. Division is multiplication. Addition, subtraction. Subtraction, addition. That's when they cross the equal signs. So we go to multiplication, as we said. You see, we have division here now because 1/3 x is the same as s divided by 3. So which means I will multiply left side and right side by 3. And that's what we have here. So the answer will be 18. 3 times 6 is 18. 3 times 1/3 is x, so s equal to 18. Another example we have, so this is division. We have used multiplication. Now here we have 5x equal to 20, so we have to, multiplication, we have to use division. So you can see that we divide the equation both sides by 5, and we get s equal to 4. Solving linear equation, we say if an equation contains one variable, and if the variable occurs to the first degree, then we call this a linear equation in one variable. So this is an example. I have 3s over 4 plus 3 equal to s minus 1 over 3. We have equal sign. We have only one variable x. So this is again, and the x is, the exponent is 1. So this is a linear equation. If the exponent is 2, it tends to something like a parabola or something like polynomial function. So if I have this question, we already know the basic principles of solving this problem, the rules. We know how to find the LCD because I have division 4 and 3 here. So the LCD can be 12. 4 can go into 12 is 3, remain as 0. 3 can go into 12 is 4, remain as 0 also. So I'll use the 12 to multiply both sides. And this will help me take out the 4 denominator, and also this will help me take out the 3 denominator. So 12 divided by 3 is 4. Then 4 times x is 4s. 4 times negative 1 is 4. So here we get 4s minus 4. Here also we have 12 times 4 is 3. So 3 times 3 is 9. 9s. 3 times 3 again. 12 times 3 again is 36. The reason why we multiply here by 3 because we have 4 here. So 4 can go into 12 is 3. Then 3 times 3 is. But here we have 1. 1 can go into 12 is 12. So 12 times 3 is 36. Then we try and combine the constant values. So I bring 4x to the left. Again, 9x minus 4x. I'll multiply both sides. So we cancel the 4x out. Then we combine 9x and minus 4x will give me 5x plus 36 equal to negative 4. So next I want to take the plus 36. So I'll use minus 36 and I have to do the same thing to the right side. So here I'll get 5x equal to minus 40. And I'll divide both sides by 5. And s will give me negative 8. We can check our answer by plugging in the value of x anywhere we see from the expression s. A to be here, A to be here. And everything on the left side should be the same as the right side. So we get -3 equal to -3. So linear equation with two variables. Here they say the steps used to solve linear equation, one variable can also be used to solve linear equation in more than one variable for one of the variables in terms of the other. Now in this case, this is not system of linear equation. System of linear equation, if we have two variables, they will give us two equations. If we have three variables, they will give us three equations, and we can find the value for each variable. But here they give us only one equation. So which means the answer will consist of either x or p. So here they say, suppose that the relationship between the firm's profit p and the number of x of items sold can be described by the equation 5x minus 4p equal to 1,200. Now the question says, how many units must be produced and sold for the firm to make a profit of 150? So this means the number of units, which will be x, we plug in 150, then we solve for the value of p. Then here they say solve this equation for p in terms of x. Then we can find the profit when we have 240 units as sold. First, they are telling us how many units must be produced and sold for the firm to make a profit of 150. So a profit will be P. Then we solve for the number of units. So let's try A. So A, as we said, profit is $150. So we plug it at the P and we get 600. We use plus 600 on both sides. We get 5x equal to 1,800. Then we divide everything by 5. We get 360. Now we can check the answer by plugging the value of x in the equation, see if it will balance. Now, second, we have 5x minus 4p equal to 1,200. And they gave us the value of, I think, p again, or x. And they gave us the value of x. They say we should solve this equation in terms of p. So we solve for p, and this is what we get. So we use the same principles. So here, 5x minus 4p equal to 1,200. I bring the 1,200 to the left side, so it becomes negative. And negative 4p to the right side, it becomes positive 4p. Then we can say p, we have to divide both terms by 4. So it will be 5x divided by 4, and 1,200 divided by 4. And the final solution will be 54x minus 300. Now, C said, okay, if we know the profit, what if we have 240 units? What will be the profit? So we just plug in the value, and then we solve it. Here the P equal to 0. Why? Because we can see 4 can go into 24. It will be 60. 60 times 5 is 300. So 300 minus 300 is 0. And normally we use the term break even. If we sell the number of products whereby we don't make no profit and we don't lose anything, that will be our break even point. So we have some stated problems too. This is the guideline to translate a stated program to arithmetic or algebraic expression. Here they say with an applied program, it is frequently necessary to convert the program from a stated form into one or more equations from which the problem solution can be found. So the following guideline may be useful in solving stated problem. The guideline for solving stated problem, read the problem carefully. We have to read the problem carefully to determine what you are to find. Use variables to represent the quantities to be found. Reread the problem and use variables to translate given information into algebraic expression. Often, drawing a figure is helpful, very helpful. Then use the algebraic expression and the problem statement to formulate an equation. Then we solve the equation. We can check our solution by plugging the value into the equation. So here we have an example given. They say Jill Ball has $9,000 in investment to invest. She has chosen one relative safe investment fund that has an annual yield of 10% and another riskier one that has a 50% annual yield. So how much should she invest in each fund if she would like to earn 10,000 in 1 year from her investment? So here we know the total profit she will earn is 10,000, and she's trying to invest 90,000. So first we want to find the amount of each investment. So we begin as following. We say, okay, let S the amount invested at 10%, and Y will be the 15%, and which will be 9,000 minus X will be the 15%. Since we have only two investments, so if S is 10%, then the total amount minus the 10%. So, and this is just a percent, so 9,000 is in dollars, so we cannot say 9,000 minus 10%. 10% of the amount. So at the moment, we don't know the amount. So we say 9,000 minus X. Now, if P is the amount of investment and R is the annual rate of yield, expressed as a decimal, then the annual earnings will be P times R, since R is the annual rate of yield and P is your investment. So using the relationship, we can summarize the information about these two investments in the table. So we have the X is 9,000 minus X for 15%. The total investment, of course, is 90,000. 10% investment, we don't know yet, so we represent it with X. Then the rate was given to us for each. So the column under I shows the sum of the earnings. I'm trying to go back. Yeah, the column I show the earnings. So the earnings will be P times R. You can see. So here we have 0.10x, which will be 10% of whatever amount. Then 0.15, which is 50%, but it will be the remaining of, after you will take X values from 9,000, the remaining. And this will be the total 10,000 we're talking about. So we can solve this, and that should give us, we open the parentheses here, and we arrange the X together, but the S is 0.15 and 0.10. So X will be 0.05x. Then we have 3,500, or X equal to 70,000. So the amount invested at 10% is 70,000, and the amount invested at 50% will be 90,000. So it will be 90,000 minus 70,000, which is 20,000. So to check, we return to the problem and know that 10% of 70,000 plus 50% of this will yield us 10,000 together. Now the next is the linear inequalities. And here we say an inequality is a statement that one quantity is greater than or less than another quantity. So example here, instead of saying 3s minus 2 equal to 2s plus 1, we say 3s minus 2 is greater than 2s plus 1. This is a first degree because the exponent is 1 and it's always a linear. So here we have a linear inequalities. We can also have less than, but the principles are the same with the equality. The difference is that when we are multiplying by negative or dividing by negative, the sign here will change opposite. So it will be from greater than to less than. So let's see an example here. We have 5x minus 4 less than 6. So if I'm solving this problem, I will see that 5x minus 4x is only x. So x is less than 6. We finish. Now the next, I have 2x minus 4 greater than x plus 6. So I would like to take the minus 4 out. So I use plus 4. And then here we get positive 4, negative 4 will cancel. So we get 2x greater than 6 plus 4 is 10. So x plus 10. Now we take x to the left, but we just use negative x to cancel everything. So we get 2x minus x will be x, and only 10 left, so greater than 10. This is another example again. We have half x greater than 8. So this means I'll multiply both sides by 2. So we'll get greater than 16. So if you have negative x less than 6, we can change the sign to positive by changing the greater than to less than, or less than to greater than. And I hope with this example also is negative 3x greater than negative 27. I will rather divide here by negative 3. That's why we have negative 1/3. And I have to do the same thing to the right side of the inequality sign. So here we get x less than negative will be positive. 3 can go into 27 is 9. So it will be x less than 9. And this is another example here. We say if for boys between 4 and 16 years of age, height and age are linearly related. This relation can be expressed as h equal to 2.31a plus 31.26. So here we say h is the height and a is the age in years. Now, to account for natural variation among individuals, normal is considered to be a measure falling within plus or minus 15% of the height obtained from the equation. So here we are going to write as an inequality the range of normal height for a boy who is again 9 years old. And here for a 9 years old boy, the height from the formula is 2.31 times 9 plus 31.26. So we get 52.05. And there will be a plus or minus 5% margin of error. So we get 52.05 of plus or minus 5%. So this means that the boy's height h is considered normal if h is greater than or equal to 52.05 minus 0.05 times 52.05, and h is less than or equal to 52.05 plus 0.05 times 52.05. And later we get the interval here, which will give us 54.65 and then 49.45. So this is another example for simple equation. So here we have 10 minus 5x equal to 3x minus 4 negative 2x plus 7. So we open the parentheses. 3x, 3 times 4 will be minus 12, minus 2x minus 14. Then I'm going to combine minus 14 with minus 12, and that will give me minus 26. Then I combine 3x minus 2x, that will give me x. Then I have minus 5x. So my goal is trying to cancel this x. So we use minus s minus s. So we get 10 minus 6s equal to minus 26. Then I'll cancel the 10. So we get minus 6s equal to minus 36. So all I need is to divide the equation by minus 6. And that will give me x equal to 36 divided by 6 will give me 6. Then the last question, we have 2/3 x equal to negative 4. So since it's 2/3, I can multiply by 3/2 to cancel. So we have 3/2 here also. And everything will cancel. So s will give me negative 6 because 2 can go into 4 is negative 2. Negative 2 times 3 is negative 6. So again, thank you for the short lectures. Again, on a simple equation. The next video, we'll see more examples. Thank you.